This K Series Frequency Follower Simulator. The simulator is a DW210 Smarty. It is connected to a K Series 680i drive via its I/O. So it would be analog I/O and discrete I/O. This savvy signal flow diagram on device directory. And if you haven't discovered your device, go to directory, discover local devices that are on your network. And if you're using a USB cable, discover via USB local device or via network if there's more than one device on there. To drill into the K Series Smarty, just left click on it and this will bring up signal flow diagram. Signal flow diagram will show the signal flow diagram for a follower system. This is master frequency input, this follower frequency input, drive speed reference, and the trimming mechanisms used to trim the drive speed reference. If we go to File, Open Savvy Panel, this is the Savvy Panel operator interface for this simulator. So in order to run the drive, we're going to turn on the follower. This enables the following and before we actually start the master drive simulator. So if we turn on the follower, and if we go to master sim control, we can set the master's reference up on what we want it to run at. And oscillation amplitude, we'll set that down to 0 for now. It's 0 to 10%. And an oscillation time. So let's go back to our home screen and we'll turn on the master simulator. So if, just to show you the difference here, if I have the master follower off and I run it, you see the reference going here, and but you don't see anything else happening, no following. So if I'll turn the master simulator down, off, and the reference goes down, turn on the follower, the reference goes up, and we're actually following. This is error generated and our trim percentage and a simulated trim error. So if I disable trim, you can see that drop off just a little bit, and I can introduce a error such as that. And now we're not closed loop. If I enable trim back, you'll see it bring it back up there and start trimming right at 0%. Disable trim, and you see that simulated error. So I'm going to bring that back down to 100%. Actually, it'd be easier if I just say 100. Check. Enable the trim, pull it right back in there. Let's go to the master sim control and introduce some process errors. So we will give it an oscillation. This will allow our process to speed up and slow down. I'll give it full 10% oscillation and say done. So now you can see our process speeding up and slowing down. We can change how fast that happens here. Make it speed up and slow down a little faster. And then go to the home screen, and we can see our follower actually following the master signal, still with very little error. To see how all this works, we'll go to File and Open Device Directory. We'll see our Smarty here again. I'm going to left click on it to drill into it to see our signal flow diagram. And we'll just step through a quick flow. This is the master frequency reference coming in. Although this frequency reference is simulated, it's simulated on page 2 with a waveform generator that goes through a set point, speed, and a ramp setting. So the output of the simulated master referencing goes to a 2N switch. So if I click on this, this is that 2N switch. This is the output of the simulated master. And then from this switch, it goes into a multiplier divider that is used for our trim. This is our trim input. And then from the multiplier divider, it goes into a trim block. This trim block passes the reference straight through to an analog reference output. And this trim input here trims 20% of the main input, and this is an output from our PID block. Our PID block is what's trimming, which is what's closing the loop. So the master reference to the multiplier divider for the trim block, and the analog reference. This is the follower frequency. This is actual frequency coming from a proximity that is sensing a gear on a motor, and 0 to 100% is 360 hertz from that gear. From the master frequency, we're going again to our trim. The trim input will go into a multiplier divider to trim that, and then to an error generator. This is a subtractor block. This is our master speed reference, and our follower speed that produces an error. The error is fed to a PID block, and the PID block is the error feedback. Our set point error is 0 because we don't want any error in it. And then our output, proportional gain up here, integral time down here. This is our integral term and our proportional error. And the output of that PID feeds that trim block. This is our drive's run. This K Series has syncs its run signal to 0 volts, so we're coming into the sync enable and time to switch to 0 volts to enable the drive. And this is our amp input from the K Series drive. We scale it for 0 to 5 volts is equal to 0 to 100% of the drive's rated current. So 7.5 volts would be 150% of the drive's rated current. This is a K340i drive, and its rated current is 3.4 amps. So we come into a scaler and set it to 3.4 amp, and it'll have a 3.4 amp output. This is then displayed on Savvy panel with a bar meter, so that the bar, when the bar reaches full scale, it reaches 3.4 amps. That's it for this K Series simulator. If you have any questions, please feel free to contact us. Hope this goes well for you. Thanks a lot.